Hi everyone. We've been looking at the unit circle, and the unit circle itself is pretty simple. It's a circle with a radius with a length of 1 unit. But the unit circle also has a lot of implications, and so we're going to be continuing to explore the depths of the unit circle in this video. You can see the objectives. These are the things that we're going to be doing. We'll be looking at some properties of trig functions and how they relate to the unit circle. So here's the unit circle, as promised. And remember how we derived it. We determined that because the hypotenuse is 1, x over 1 is equal to cosine theta, and y over 1 is equal to sine theta. So any one of these points that are x and y are actually, on a unit circle, cosine, sine. And remember, that's alphabetical, both of them. So if I wanted the cosine of 2 pi over 3, I would go find the angle 2 pi over 3 in the second quadrant and look at the x-coordinate so that the cosine of an angle is the ratio -1/2 because that's in the second quadrant. If I wanted the sine of 11 pi over 6, right, I would look for that in the fourth quadrant. 12 pi over 6 is 2 pi. Right? 2 times 6 is 12. Anyway, so this is sine. Sine's in the fourth quadrant, which is negative. And so that is the y-coordinate, so that would be -1/2. And we've done a lot of work with that, and we will continue to do work with that because it's hard to memorize for some of us, and so, including me. And so there are ways to derive it. And so we're just going to continue to practice it until we can pull those values out of our memory. So in this example, we're going to depart from the unit circle because the hypotenuse of this triangle is not equal to 1. It's not equal to 1. But I can find it. And I can find the 6 trig ratios to this angle theta, right? The 6 trig functions are sine theta, cosine theta, tangent theta, and then their reciprocals. So we have cosecant theta, secant theta, and cotangent theta. These are all the trig ratios, all 6 of them. And just a hint, I always write them in this order. Because if you'll look at this, sine over cosine is tangent. Cosecant over secant is cotangent. Also, sine and cosecant go together. Cosine, all those go together. So that's just a hint. That doesn't help. Well, it does help us with the problem, but it helps me to have it always in the same order, and that order makes sense. All right, so I need this value. I need the hypotenuse of this triangle. I need the hypotenuse, right? So I'm going to use the Pythagorean theorem. This is a leg, this is a leg. So I have 3 squared plus 4 squared is h squared, the hypotenuse squared. So I have 9 plus 16, which is 25, is h squared, so h is 5. Now some of you are like, Ms. Bonifield, why did you go through all of that? Everybody knows that this is a 3, 4, 5 right triangle. It's a Pythagorean triple. Well, that's awesome if you remember that. But what happens if you lose your mind or it's a different type of number and you need to figure out how? You can always rely on the Pythagorean theorem, always, in a right triangle. Okay, so that now that I have all of those, I can use my trig ratios to find it, right? Sine is opposite over hypotenuse. And its reciprocal function is cosecant. So I'm just going to flip that back over. Cosine is going to be 3 over 5. So that means secant is going to be 5 over 3. Tangent is opposite over adjacent. And cotangent is that flipped over. Now look at this. Remember I said this over sine over cosine is tangent. Well, 4/5 divided by 3/5 is 4/5 times 5/3, which is 4/3. So you see how that works? So using the relationships between the trig ratios will really help you in these kinds of problems. There are 3 properties of sine and cosine functions that we're going to look at. And the first one is that sine and cosine are periodic functions of period 360 degrees or 2 pi. Okay? So what that means, if you've ever seen the graph of sine or cosine, is that it is a periodic function. In other words, it continues to repeat the same patterns over and over and over again. And so the functions repeat every 360 degrees or every 2 pi. So every 2 pi there's another exact pattern. And it's the same for cosine. Cosine just starts up like this. That's not very good. It starts up at the top. Okay, so we're going to use that because remember that we said that at 0 and 2 pi it has the same value because they are coterminal. This is basically talking about coterminal angles. So at 8 pi, right? So here I'm going to use my unit circle. Here's 0, right? So 8 pi, this is 2, 4, 6, 8. I end up here. So the sine of 8 pi is the same as the sine of 0, which is 0. So this one was an easy one because they're just 2 pi. Sometimes they're a little more tricky, like 17 pi over 6, right? And then you have to figure out where that is. But remember that all the way around 2 pi, the easiest way to find, so if it's pi over 8, right? If it's pi over 8, and I want to know what 2 pi is, that's going to be 16, 2 times 8. If it's 5, right, it's going to be 10. So on 6, it's going to be 12. So if I take one of the 2 pi's out, subtract 12 pi over 6, then I get 5 pi over 6, which is over here. Okay, so that's how you use that. Now this one's kind of cool to know, and I don't know that you're going to use it all that much. You probably saw it in geometry, but sine and cosine are complementary, right? Their angles are complementary. So for instance, and that's what it says here, unpack the notation, cosine t is equal to sine of pi over 2 minus t, and sine t is cosine pi over 2 minus t. Well, okay, what does that mean? Well, pi over 2, we know in radians, is 90 degrees. So I wrote it over here in degrees. The cosine of 30 degrees is equal to the sine of the other angle, right? So if this is 30 degrees, then this one has to be 60. And a cosine is adjacent over hypotenuse, right? So then what would the sine of this one be? It would be the same side over hypotenuse. So the cosine of 60, the cosine of 30 and the sine of 60 are the same value, which is square root of 3 over 2. So that would mean then that the sine of pi over 6 is going to be equal to pi over 2 minus pi over 6, or the cosine of pi over 3, which is 1/2. Okay? The tangent of 45 would be the same as the cotangent of 90 minus 45, which is 45, which is 1. So you can see here that we could use this. This will be used less frequently than some of the other properties. So the next and last property is that sine is odd and cosine is an even function. These are the properties. And so I wanted you to look at some graphs that were even and odd functions, right? It says a function is even if and only if, if and only if f of a is equal to f of negative a. And graphically, even functions are reflections in the y-axis. And you can see that here. See, that's, and also this function right here. See how it is right here at the y-axis. They look exactly the same on both sides. Not true for this one. Okay, so this top one is cosine. And the bottom one is sine. This one, however, the sine function is going to be symmetrical around the origin. So if I flipped it over, if I went around like this, I could actually lay it on top of it again. And here's your odd function. I know, look at this screen. There's a lot of words on the screen. But mostly what you get in the book is you get something like this that's in the box. And it says f of t is an even function if f of negative t equals f of t, and it's an odd function if f of negative t equals negative f of t. And you look at that and you think, oh my gosh, it's notation. You know, what does this even mean? So that's what the rest of this is about. So if you have a pretty good grasp of function notation, listen through this. If this is something you still struggle with, and a lot of students do, believe it or not, even in calculus I see that, then take the time now to begin to unpack this notation so that it makes more sense to you. Okay, so like this, f of t means f is a function that has t as a variable. F of 1 means that in the function t, evaluate f by plugging in a 1 for all the variables. Okay? F of negative t means that for every variable of the function, I'm going to substitute a negative t. So f of negative 1 means that I'll evaluate it by plugging in negative 1 for all the variables in the function and see what happens. What does it look like in the original function? All right, so this in blue, g of x means the function is called g, and so this is function g, that's its name, and the variable used in the function is x. So for instance, g of x is equal to 2x plus 3. So if I wanted to do g of 1, then I would put a 1 everywhere there is an x, whoops, that's a plus, and so that would be 5. Okay, pretty simple. Now, graphically, what this means is if I look at this function right here, which some of you will recognize is the quadratic function, you know, just a parabola, regular parabola with a vertex at 0, 0, over 1, up 1, so it's just your basic x squared, right? This is an even function. And the reason I know it's an even function is that if I pick a value, right, 1, here's f of 1 is going to be the y value, 1. T is also 1. F of negative 1, right, is also 1. T is negative 1. So f of t is going to be, this should not say f of t. This should say f of negative t, right? If I put a negative in, it's going to equal the original function. It's going to be the same thing. Okay? So if I say that the cosine of theta is 4/5, then the cosine of negative theta is also going to be 4/5. All right, so this one is an odd function. This is an odd function. All right, so odd, and if you'll notice here, even is symmetry. It has to do with symmetry. It's symmetrical about the y-axis. And if you notice on here, odd is symmetrical about the origin. All right, so f of 1 is 1, where t is 1, and t is negative 1, but this one is negative 1. So notice that these two values are not the same as they were over here. So once again, f of negative t is going to be f of t negative. And that's where they get this function. So if this is true, if this actually happens, then I can use that. So here are what the problems look like when you're using the properties of sine and cosine, right? You'll be given that sine t is an angle, 3/5 is a ratio. So the ratio of the sides opposite over hypotenuse is 3/5. And then using the even odd properties, using properties of the unit circle, its periodic functions, use the same ratio to write the ratios for these functions. All right, so sine, as you recall, sine is an odd function. All right, so the sine of negative t will be negative, whatever the ratio is for sine t, so negative 3/5. Cosecant is a reciprocal function of sine, right? Sine doesn't change, SIGN, sine, so this is going to be 5 over 3. Now cosecant, well, cosecant uses sine to derive, so it's also odd. So this would be negative 5/3. Tangent. To get tangent, I would need a triangle, right? So here's my angle. This is t. I always put theta, but that's t. So this is 3/5. Remember, this is 4. So tangent is going to be 3/4. Now sine of pi minus t. Well, t is going to be, if we assume t to be positive, right, looking at a unit circle, if we assume sine to be positive, it's got to be in first quadrant or second quadrant, right? And so if I take it here and I take pi minus t, say it's here, and I do pi minus t, then I'm going to get this angle, which is in this quadrant, which is also positive. So the will be the same, 3/5. But if I add pi to it, I'm going to change quadrants, even if I go here. Either way, right, if I add pi to it, I'm going to change quadrants where sign is negative. And so that's how that goes. All right, same thing with cosine, only cosine's even. Now, to complicate it, they give you a negative ratio, right? The cosine of an angle t adjacent over hypotenuse is negative. So where is cosine negative? Well, cosine's negative in 2 and 3 quadrants, all right? So because it's an even function, whatever the ratio is going to be the same as negative t. So the cosine of the negative angle, remember because it's reflective over the y-axis, is also going to be the same. Secant, you're going to flip it over, keep the sign, negative sign, the same. The secant of, once again, we suspect that since secant is a reciprocal of cosine, it's going to be the same thing. It's also going to be even, so this would be -4. Now cosine, let's take a look. If I have an angle in the second quadrant and I subtract, I get this little bitty angle, right, which is over here, and so this is going to be positive. Same ratio, but positive. So what these are looking for are positive and negative. Right? So if I take this angle and I add pi to it, I end up over here where it's positive. Same here. If I add pi to it, I end up positive. So this is 1/4. So there's a lot to unpack here, a lot to think about. I hope you'll take some time to think through these properties, and then we'll be practicing these in class. See you then.